Hi there, welcome to Math 6, Unit 4, Lesson 5 on How Many Groups, Part 2. Okay, so we're going to be using blocks and some diagrams to understand more about division with fractions today. Okay, so here we go. We're going to move to this here. Today's lesson, I'd say it's a little more challenging in some ways. So hang in there and just try to get the understanding part down, all right? Because there's some tricky shortcut things you could do to make it like work. But we really want you to understand how this all works, okay? So hang in there, here we go. First of all, reasoning in fraction strips. Write a fraction or a whole number as an answer for each question, and if you get stuck, use the fraction strips and be prepared to share your strategy. So the first question says, how many halves are in 2? And so when we look over here, what we notice is that I have a full 1 right here, right? This is a full number 1. And I have another one here. So this entire fraction strip represents 2, right? Right down the middle, that's where our 2 is going to be. Okay? So when I look at how many halves are in 2 whole things, I can really kind of circle up and count them up. I have 1 here, I have 2, I have 3, and I have 4. So I could say that there are 4 halves inside of 2, right? What we're thinking about here, just to kind of get you thinking ahead a little bit, is we're saying if I take 2 and I divide it into halves, that's going to tell me how many halves I'm going to have, how many groups I would make if I make them each 1/2 long, right? So that's what we're looking at there. The next one says how many 1/5 are in 3. Now the 1/5 row is right here, and we can see that in 1 I have 1, 2, 3, 4, and 5. So if I have 5 that are inside of 1, and I'm talking about 3, then I'm going to take my 5 and multiply it by 3, because I would do this again, right? If I do the second one, I would go 6, 7, 8, 9, 10, and then I would do it one more time for the third one, and I would end up with 15. So what this problem is saying is if I took 3 and I divided it into fifths, how many groups of 1/5 would I come up with? I'd end up with 15 of these little squares. For number 3, it wants to know how many 1/8 are in 1 1/4. Okay, so that one's a little different to look at here, because 1 1/4, I can look at 1 goes all the way to here, and 1/4 is one additional one right there. So 1 1/4 would be like this box area here in blue. That's one whole, right? Here's one whole one here, plus the additional 1/4. That's 1 1/4. That's how long it looks on that fraction strip. So if we're asking about how many 1/8 are inside that area, it'd be a little bit like taking my fraction strip here. We draw a line down this direction here to get to the end of the 1/8 category, just so we can visually see what's going on. And we can see how many 1/8 are inside of this bar. Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 10. So we know the answer is 10. That's great. But what are we talking about in terms of division? We're saying we're going to take the 1 1/4 bar and we're going to divide that into 1/8 segments. And when we do that, we're going to end up with 10 segments. That's the idea there. Okay, and so if you rewrote the mixed number here, this is 4 times 1 is 4, plus 1 is 5. So you also could write this as 5/4 divided by 1/8 there. Okay, and that still equals 10. So just another way of looking at that one. Let's look at number 4. 4 says let's take one whole bar and divide it into 2/6. Well, it might be helpful here to think about, well, what is 2/6? 2/6 can be reduced into what? It can be reduced to 1/3. So if we're going to take the 1 bar and we're going to put it into groups of 1/3, how many 1/3s do we have here? Well, we have 1, 2, and 3. So we could say that 1 divided by 1/3 or divided by 2/6 doesn't make a difference. 1/3 equals 3. For number 5, it says, well, let's look at 2 full chunks for sections, and let's divide that into 2/9. All right, so 2/9. So that one's a little different here, because what is a 2/9? I don't see a 2/9 on my little chart, but what I know is that 2/9 is the same as a 1/9 plus another 1/9. That's a 2/9, right? So if I can group things together in pairs, here's our 1/9. This is a 2/9. That becomes 2/9, 2/9, because I'm putting two together, yeah? So two together, two together, two together, two together, and two together. So how many little pink groupings did we make in our 2? Because the whole thing's 2. We made 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we would say that 2 divided by 2/9 equals 9, because there are 9 of those within that. Okay? And then finally, when we look at the last one here, we have 4 divided by 2/10. Now again, I don't see a 2/10 on here, but I could reduce 2/10 and say that 2/10 is the same as what? Can you reduce that? Yep, 2 goes into 2 one time, and 2 goes into 10 5 times. So we're thinking really about 4 divided by 1/5. Okay, so here's again my 1/5 row. I can look at the 1/5, and I know I'm going to do it whatever I have in the 1/5 row, I'm going to do it 4 times. So in one of the 4/5, I have 1, 2, 3, 4, 5. Right, so I have 5 of those, and I'm going to multiply that by 4 because there's 4 altogether. So I have 1, 2, 3, 4, 5 1/5 right here, and I'm going to do that 4 times. So 1, 2, 3, 4, and 4 times 5 is going to be 20. Okay, so this is how the fraction strip helps you kind of visually see how some of these fractions work together. I will say, after kind of playing with it a little bit today and yesterday, that some work a little nicer than others. It's easier to see how they kind of line up. Sometimes you'll get some fractions that just, it's hard to draw a little chart like this, but the ones we picked do work well. Okay? All right, let's take a look at activity number 2. It says your teacher's going to give you some pattern blocks, as shown here. Use them to answer the following questions. All right, so we have our pattern blocks. We've used them before, and I have mine off the side here. And it says, if a trapezoid represents one whole, what do each of the following shapes represent? So in this case, today, we're saying that this trapezoid is our one whole. That's our one whole, right? Now, knowing what we know about trapezoids, we know that a trapezoid, compared to one triangle, that there are, in our case here, 1 and 2 and 3 triangles inside of one trapezoid. So if the whole is now the trapezoid shape, what do the triangles represent as, if written as a fraction? We would say that one triangle is 1/3 of the whole trapezoid. Again, we're comparing it to trapezoid this time, so one triangle is 1/3. There's 1 out of 3 of the whole thing. When I look at something like a rhombus, so one rhombus here, here's our rhombus, and again, we could think about it, when you think about the triangles, right, there's like 3 there. The rhombus is taking up not the whole thing, so it's not a whole one, but if you think about the triangle, we have 1, 2 of the sections filled up by the rhombus out of the 3. So one rhombus is 2/3 of the trapezoid, 2/3 of the whole. When you talk about a hexagon, though, well, that's a little different, isn't it? Because now the hexagon is going to cover it up plus more. Well, how much more? It's going to be one whole trapezoid and one additional trapezoid. So in reality, the hexagon, one hexagon, has a value of 2 if we're saying that the trapezoid represents the one whole, because it takes 2 of them to cover up, or we could say this hexagon covers up 2 of the trapezoids. All right, hope that kind of makes sense there a little bit, in using the trapezoid as the whole this time. Last time I used the hexagon. So now it says, let's use pattern blocks to represent each multiplication equation and use the trapezoid to represent the whole. Okay, so this is our whole. Got it. So 3 times 1/3. Now we said that the triangle was a 1/3. All right, so this times this times this makes what? It makes the whole trapezoid. So what we're saying here is that if I take 3 triangles, right, and if I do a third and a third and a third, that's going to equal one whole trapezoid, because 3 groups of a third, 1, 2, 3, is the whole thing. And that's what we're showing here with this picture. Okay? Now what if I do 3 times 2/3? Well, we said before that the 2/3 was the rhombus, right? Again, knowing that the trapezoid is our whole, let's take 3 rhombuses here. Okay? And we have 3 of the 2/3. So there's 1, there's 2, and there's 3. And the question is, it says that it equals 2. Well, how does that equal 2? Well, it's saying that it equals 2 of these, because that's our whole. So let's do this here. If we push these together, we already know that one of them is going to work like that. And if we take our other one, what can we do? We can turn it upside down, and we can see that indeed it actually makes 2 holes, doesn't it? Just like that. Okay? So visually what we're saying is that we're saying we can take the rhombus, and another rhombus, and another rhombus, and we can turn these into and show that this is a trapezoid shape here, and another trapezoid shape here, and we actually have 2 trapezoids there in that shape. Okay, so that's what we're looking at. Number 3 says, Diego and Jada were asked how many rhombuses are in a trapezoid. Diego says 1 1/3. If I put 1 rhombus on trapezoid, the leftover shape is a triangle, which is 1/3 of a trapezoid. Jada says, I think it's 1 1/2. Since we want to find out how many rhombuses, we should compare the leftover triangle to a rhombus. And a triangle is half of a rhombus. Is the answer 1 1/3 or 1 1/2? That's a good question. So, what we're going to say here is that you want to think about it for a little bit. So, do think about this. Don't just skip ahead here. What we're talking about is that if you have a trapezoid, we know that we have a rhombus inside, because the question is how many rhombuses are in the trapezoid. We know for sure that we have 1, right? That is definitely 1 whole rhombus is inside of there. The question is, what do we call that part? What do we call that part there? And because we're comparing this to a rhombus, then we're going to say that the triangle is what fraction of the, in our case here, what fraction of the rhombus. So this leftover piece is what fraction of the rhombus. This is 1 whole rhombus, and this part here becomes half of a rhombus. So in all, we have 1 whole rhombus here, and we have half of a rhombus there, for a total of 1 1/2 rhombuses in that picture. And that's the idea. And we do that because we're talking about how many rhombuses are inside that trapezoid. Okay? This is going to come up later when we start looking at a tape diagram and talking about how many 1/4 are inside of 2, those kind of things, right? So for example, let's just say, well, let's do it like this. If I had a whole, just 1, okay, and I asked you how many 1/4 are inside of there, I'm going to break this up into fourths. I know that my whole thing is 1, and I would say, well, I have 1, 2, 3, 4. I have 4 1/4 inside of there. If the whole thing is 1, and I'm asking you how many 1/4 in there, I'd count them up as 1, 2, 3, 4 of those. I don't change and say it's something different because I'm asking how many fourths are in there, just like we're asking how many rhombuses are in there. That's what I measure by. Okay? All right, number 4. Select all the equations that can be used to answer the question, how many rhombuses are in a trapezoid? All right, so what we're doing here is we're taking the whole trapezoid, right, and we're dividing it by what the rhombus is worth, which is 2/3. So we would say C is going to work. And since C is going to work, then we can also write it as a multiplication problem, and the matching multiplication problem is here. We would say some number of groups times 2/3 will equal 1. right? And in our case, we said that it was 1.5. Now 1.5, double check this here, 2 times 1 is 2, plus 1 is 3, so that's the same as 3 out of 2. So let's try letter B real quick. What is 3/2 times 2/3? 3/2 times 2/3 is 3 times 2 is 6, 2 times 3 is 6, and that equals 1. So indeed we can prove that this is actually true. This is a true statement because the half, 1.5, is 3/2, and it works out well for us. Okay, let's look at the optional activity here. This was one that you may have done in class, or you may not have, hard to say. Get a quick drink of coffee. Okay, it says for each situation, draw a diagram for the relationship of the quantities to help you answer the question. Then write a multiplication equation or division equation for the relationship. Be prepared to share your reasoning. So the distance around a park is 3/2 of a mile. Noah rode his bicycle around the park for a total of 3 miles. So how many times around the park did he ride? So the picture is something like this, right? We have a park. So here's our park. All right. And we know that one time around the whole thing is going to be 3.5 miles. And we want to know, he did this, we want to know how many times he went around, because 3.5 times some number is going to get us to 3 miles total. He's going to do it again and again until he gets to 3 miles. That's the idea. Okay, the other way of thinking about this would be what? We could say you're taking 3 miles and we're dividing them into 3/2 segments to find out how many times he went around the park. That's the idea there. Okay, so if we take our 3, go 1, 2, and 3, right? That's our 3 miles. We know we went around 3 miles. Way to go. And each time he went around, he goes, it's a 3.5 mile segment. Let's break these up into halves. Okay, breaks up into halves. So I'm going to divide that as a half right here, a half right there, and a half right there, just so I can see my half pieces. And now every loop around the park is 3 out of 2. Now these are all half segments, right? This is a half. We've already established that. These are halves here in these little chunks, right? So 3 out of 2 means I'm going to group 3 of these things together. In essence, I'm going to say that 3.5 is going to be 1, 2, 3, this much right there. So this value is 3 out of 2. This value here, 1, 2, 3, is also 3 out of 2. So when we take a look at it, what we're asking for is we're saying if I have 3 miles and I break it up into 3.5 segments, how many 3.5 mile segments are inside of 3? And what we notice is that there are 1, 2, which means he would run around the park 2 times, right? Let's see if that's true. If we do 3/2 times 2, what do you get? Well, 3 times 2 is 6, and then 6 divided by, well, I'll do this, is 6 over 2, and 6 divided by 2 is 3, so that is correct. So we would say he went around the park 2 times. Okay, let's look at the next one, number 2. It says you need 3/4 yard of ribbon for 1 gift box, and you have 3 yards of ribbon. How many gift boxes do you have ribbon for? So we have 3 yards of ribbon, okay, and we're going to divide that into 3/4 segments, and we want to know how many boxes we can wrap with that. Or we can also think of it as I have 3/4 segments, right, and I'm going to be wrapping boxes, and in total I'm going to use 3 yards of ribbon. That's kind of our idea right there. So let's come back over here to our segments. Once again, we're going to go with a 1 and a 2 and a 3. Okay, that's my 3 yards. Now for each of the yards, because I'm dealing with fourths, I'm going to go and break each one up into fourths because I'm dealing with fourths right there. So I'm going to go 1, 2, 3, 4. and then 1, 2, 3, 4, and then 1, 2, 3, 4. So all I did is I took the holes of each one of the hole, there's 3 holes here, and I broke it into fourths. Okay, now we want to break ours into 3/4 segments that are 3/4 long. So for a 3/4 is going to be 1, 2, 3, right? That's 3/4. I'm going to do 1 from here to here. 1, 2, 3. That's 3/4. Okay, so I could shade them like this if you wanted to. Right, that's a 3/4 there. We have a 3 out of 4 there. Here I have a 1, 2, 3 out of 4 here. And I have a 3 out of 4 there. 3 out of 4 there. So how many 3/4 segments did we create? We made 1, 2, 3, 4. Meaning that if I took the 3 yards of ribbon and I chopped it up into 3/4 lengths, I could do that 4 times. Okay, and we can double check that. Let's use our multiplication problem to check it this time again. So 3/4 times 4 of those, what does that equal? Well, the 4's cancel out and you're left with 3, and that equals how many yards we have. So that does work for that one there as well. Let's look at number 3. The water hose fills a 1/3 gallon per minute, bucket 1/3 gallon per minute. How many minutes does it take to fill a 2-gallon bucket? Okay, so we have 1/3 per minute. We're wondering how many times or how many minutes it would take in order to get to 2 whole gallons. Or another way of thinking about it, I have 2 gallons and I'm going to divide that into 1/3 segments to find out how much time it would take. So let's take our 2. We'll do 2 this time. So 1, and I'll draw another one for 2. Right, this represents 2 whole segments. This is my bucket here. Now I'm dealing with thirds, so let's divide this into thirds. So there's 1/3 all the way across, and then divide this into thirds here. So the first thing was make my holes, and then I look at what I'm playing with here, the thirds, to make it into third sections. Right, that's a 1/3, it's a 1/3, a 1/3, a 1/3, a 1/3, and a 1/3. Now because I'm dividing by 1/3, I know that this part right here is 1/3, as is this one, and this one, and this one, and then this one, and this one. A lot of 1/3s in there, right? So how many 1/3s are there in total? We have 1, 2, 3, 4, 5, 6. So I end up with 6 1/3s. 6 1/3s are inside of 2. So let's see how that works for our multiplication problem. So we said 1/3 times 6. What does that equal? That gets you 6/3, which reduces to 2 and matches there. So again, we can prove that that is actually how that works. Okay, so hopefully that's helpful there, and I was a little slower going through that, but that's going to help you with a couple of the homework problems and also moving forward there. But that's just a little bit deeper thinking than normal. Okay, and again, there are shortcuts, but it doesn't mean you'll know what's going on. So let's take a look at summary. Summary here, we can think of, we have example of, we have a batch of cookies, requires 2/3 cup of flour. How many batches can be made with 4 cups of flour? So the idea is we're taking the 4 cups and we're breaking it up into 2/3 kind of segments, right? Now you did it with a block here to visually see this. This is our 4 cups, and if the 4 cups are broken up into the rhombuses, which represent 2/3, we can see we have 1, 2, 3, and then 4, 5, and 6 segments of 2/3 with using the rhombuses there. You could also do it with other kind of diagrams. You could demonstrate that with the diagram right here, to show how that works out for this one. This is our 4, and each one of the 4 segments is divided up into thirds, and they're picking out where the 2/3 are going to be, right? If you look at kind of the way I drew it before on my little chart, how I was doing it like a long one, right? Like 1, 2, 3, let's go back this way since I ran a room, and 4. And then we're taking, because we're dealing with thirds, we broke them into thirds. So we went 1, 2, 1, 2, 1, 2, 1, 2. And because we're doing 2/3 segments, we're saying how many 2/3 segments are inside of each of these. Well, we have 1 right here, that's 2/3. Another one here is 2/3. 2 right there makes 2/3. 2 there is 2/3. 2 there is 2/3, and 2 there is 2/3. So how many is that? 1, 2, 3, 4, 5, and 6. So the same answer, just another way of visually showing you what's going on with that problem. Okay, so I hope that helps you so far. Before we move on, let's do one more thing. Okay, let's take a look at one more little sample problem here, because this will help you out a bit with your homework. Because we did a lot where we're dividing whole numbers. I want to show you real quick what happens if you do something like a fraction. 1/2 divided by, let's do 1/4. What would that look like? So to do this one, let's think about our fraction bar here. Okay, we have one whole right there. Now, because I'm talking about a half, I'm only going to be dealing with half of it, right? This is what I'm starting with here, is the half. So this is my half segment. Now, when I take my whole bar, I'm going to divide the whole bar by that number there, the fourths, right? So I divide the whole bar by fourths, that's chopping it there, there, and there. So when I do a half divided by 1/4, I'm asking how many of these 1/4 segments are inside of the half. Well, the half is what? The half is just right here. Okay, this is my half. So this is my half segment. And what I'm wanting to know is how many of the 1/4 are inside of that. Well, we've already established that this is a fourth and this is a fourth. So we would say that we have, if this is a 1/4 and this is 1/4, we would say that we have 2 inside of there, right? We have 1 there and 1 there. So 1/2 divided by 1/4 equals 2. And we could check that out by doing multiplication, right? We could do 2 times 1/4 to check that out. What is 2 times 1/4? 2 times 1 is 2. 4 times 1 is 4. We reduce that to 1/2 and it matches and we're good. So you can do a fraction bar with fractions too. It does work out. Let me show you another one. Okay, what if we did 1/3 divided by a half? Okay, so again, we're going to start with our whole bar. This is our whole bar. And we're going to divide the whole bar into thirds. Okay, so this is the 1/3 that I'm dealing with. I'm only really looking at this little chunk right there. That 1/3 is what I'm dealing with there. That's my 1/3. Okay, so in this case, this is my 1/3. This is the area I'm going to be talking about. I want to find out what's going to fit in there, but I'm going to take the whole bar and I'm going to divide the whole bar into half. Well, that whole bar half division would be where? That would happen right here, wouldn't it? That's dividing the whole bar into half. So when we take a look at this one, the problem with this one is the half goes beyond the pink, doesn't it? Right? So the half goes beyond the pink. It's more than the whole pink. So what we would say in this case here is, when we're talking about this one, is it's not going to be a number greater than 1, right? Because I don't even fill it up, right? The half is too big. The half is bigger than the pink. So I'm dealing with a number less than 1. So how much of the pink is actually filled in? Well, let's do this. Think about this real quick. If the half is dividing the third right down the middle, okay, then we could probably divide this one down the middle there, this one down the middle there, and we're dealing with, really, we're dealing with those fourths again, so to speak. And what we look at here when we chop this up is we have 1, 2, 3 of these little segments inside of the half, right? Now, of those segments, how many of them are in the pink box? Well, there's 2. So there are 2/3. 2/3 are inside of this space here, because I just turned that half area into thirds and we're only getting 2 out of the 3 that are there. Alright, so let's see what happens here if we multiply, because what we're saying so far is, if this is true, 1/3 divided by 1/2 equals 2/3. Well, let's do the multiplication problem. Is 2/3 times 1/2 equal to 1/3? Well, 2 times 1 is 2, 3 times 2 is 6, and that reduces to 1/3, and indeed it does match. Okay, so just another example there. You will have one like that on the homework or something similar, so be ready. It's the first one. All right, so go ahead and get started on your homework, and we'll come back and check it together in just a minute. All right, here we go. Homework time. Use the tape diagram to represent and find the value of half divided by a third. Mark up and label the diagram as needed. So what we can see is we took a whole, right? And we took that whole and we divided it into a half. So let's see here. We got the right marker here. So we took the half, which is this one here, and we can see that what we've done is we've said this is the half of the whole thing. That segment right there, right? That's the half part we're talking about. That's why it says half. Now, what we did after that is we're going to divide that half into thirds. So what was nice here is they took the entire whole thing, right, and they put that into 1/3 chunks. So there's a third, there's a third, and there's a third. What makes it a little visually a little weird to see is you might be looking and saying, well, but aren't those 2 boxes, right? 2 boxes there. Yes, but that's a total of 1, 2, 3, 4, 5, 6 boxes, right? So 2 out of 6, which is the same as a third. So visually, it may not quite look right to you. So what we're wondering here is, in this case, is we're wondering how many of the yellow boxes or yellow things are inside of this little pink area. And what we see is that this chunk right here, that 1/3, is inside of the pink, right? So we have a whole one, right? There's a whole, there's one full 1/3 right there. That's what that one represents. But then I have this part right there. Well, how much is that? Well, 1 square, it's 1 square out of the 2 needed to make a third. So realistically, this is going to be half of that, right? So it's going to be half of the whole 1/3. So I have 1 full 1/3 and I have half of a 1/3. So what I have really is I have a whole plus a half, which equals 1 1/2, or I could write that as an improper fraction and write it as 3/2. All right, and that's what we're showing there. So that's the idea behind what you see right there for how that works. That is 1/2 divided by 1/3. So what is the value of 1/2 divided by 1/3? Use pattern blocks to represent it to show a different way. Okay, so here's another way. So if we're going to say that a half divided by a whole, if we know that the whole, the hexagon's a whole, and we're talking about the half, and the half is here. Okay, so that's our half. So I can just sketch this out for you real quick. So here's our hexagon half. That's our half. And we're going to take the half and divide that into divided by 1/3, right? So we're going to chop that into 1/3. Now, in terms of a third, if this is the whole, what is a third of that? A third of that is going to be our rhombus. 1, 2, 3, right? Because it takes 3 to make that. So the question then is, how many rhombuses are inside of the trapezoid? That's what we're looking at. And so when we look at our trapezoid, we know we can chop that up and we have 1 full one right there. So we have 1 whole rhombus inside the trapezoid, but we also have that triangle piece. And a triangle is what? It's half of the rhombus. So because we're looking at the rhombuses that are inside there, we have a 1 plus we have a half, which is that 1 1/2 or 3 out of 2, depending how you want to look at that there. Okay, and that's the idea by looking at this one, looking at the pattern blocks. Same idea. So you can do it with pattern blocks, you can do it with the that kind of tape diagram like that, whatever works for you. Number 3, use a standard inch ruler to answer his question, then write a multiplication equation and a division equation that answer the question. So how many halves are in 7? So here's 7 out to here, and halves are going to be in between. So we have 1, we have 2, and 3, and 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So we have 14 halves inside of there. As a division problem, you might say that we're taking 7 and we're dividing it into halves to find out that we have 14 groups of that. As a multiplication problem, we could say we have 14 groups of 1/2, which combine to make a length of 7, something like that. When you look at how many 3/8 are in 6, a little bit small to take a look at there, but you can take a look and count them up. How many 8s are in 3? So there's 8, sorry, so in 6. We can count out, you can count the 6 if you want to. What I found is that if I went to the 3, I got a nice number to look at here at this point here. Because when I do the 3/8, that's going to be 1, 2, 3, so it's this spot. Then 1, 2, 3, this spot. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and then 1, 2, 3, and 1, 2, 3. I landed on a line there, right? So I have 1, 2, 3, 4, 5, 6, 7, 8 of them in 3 inches. I want to go to 6 inches, so I'm going to double that. So I would do 8 times 2, which is going to be 16 to find my answer there. So we would say that when I do 6 and I divide it into 3/8 segments, I have 16 of those all the way across. Multiplication would be 16 times 3/8 equals 6. And finally, our last one here, how many 5/16 are in 1 7/8? Okay, so let me erase up this marks here and see what we have here. So 1 7/8 is going to stop right there. That's our boundary line for 1 7/8. And I want to know how many 5/16. Those are the itty bitty ones, right? So that's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. So I had 1, 2, 3, 4, 5, 6 of those inside of there. So as a division problem, we're saying 1 7/8 divided by 5/16 equals 6. And as multiplication, we're saying 6 times 5/16 equals 1 7/8. And that's what we're looking at there. Okay. Next one says, use a tape diagram to represent and answer the question, how many 2/5 are in 1 1/2? Okay, how many 2/5 are in 1 1/2? So we're talking about 2/5 in 1 1/2. And again, as a division problem, we're saying 1 1/2 divided by 2/5. And we're looking for what's inside of there. So what we can see is that, first of all, we have our 1, which is here, and then they went out half of 1 there. Okay, so that's what this is, 1 1/2. That's this segment right here is the 1 1/2. That's why that's drawn there. Now, they went ahead, because we're doing fifths, notice they took the 1 and they put it into 5 bars. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So what we want to know is how many 2/5 are inside of this whole segment here. So 2/5 is 1 out of 2. And so we can look at this and say, well, here, oh sorry, it's 2 boxes. So here's 1. That's a 2/5 right there. Okay, agree with that so far? We have a 2/5 here because we have 2 out of 5. So that's another one. We have another one here. So here's a 2 out of 5. And then we have that part there. Like, well, that's not going to work out too well. So far we know we have 1, 2, and 3. But what do we do with this one here? What we can see is we know we have that this one would be half of 1, right? Because it's 1 box. 2 boxes make a full. We have half of 1, but we also have half of a half. Well, what is half of a half? Half of a half is a fourth, and a half plus a fourth is going to be equal to 3/4 of the whole thing. So altogether, we would say we have 3 3/4. Now, can we check that out? Well, let's just see. If we did 3 3/4 times our 2/5, do we end up with 1 1/2? Well, this becomes 4 times 3 is 12, plus 3 is 15, so that becomes 15 over 4 times 2 over 5. I can reduce the 5s and 15, that becomes 3 over 1. 2 goes in here 2 times, 2 goes in here 1 time, so 3 times 1 is 3, and 2 times 1 is 2, so I get 3 over 2, which is the same as 1 1/2. So the whole numbers are pretty easy to see. It's this extra little piece here that might trip you up a little bit, right? But we can see that we're comparing to the 2/5 that I have half of a 2/5 and half of a half, which is 1/4. So that's what we do for number 4. That's a little more tricky, okay? Number 5. By multiplication equation and division equation represent each question and statement or diagram. So there are 12 fourths in 3. Okay. So we have 3, and we're going to divide it by fourths, and we're going to have 12 of them. So if I take the whole number 3, like 3 yards ribbon, and I divide it into 1/4 lengths, I'm going to get 12 of those. Okay? Over here, we have 2, and we're dividing into 1, 2, 3, 4 sections of a half. So I can think of that as 2 divided by 4, which equals a half. I could think about it as a half times 4 equals 2. I should back here real quick. I needed multiplication. I could do 12 times 1/4 equals 3. So those are a couple ways. There are other ways too. That's just what we have so far. How many 2/3 are in 6? That's doing a 6 and dividing it by 2/3 to find out what that's going to be. And in our case here, 6 divided by 2/3 is actually going to be equal to 9. Okay, is there a way to show that there? Yeah, we can do that. So here's 1, 2, 3. Let's do 3. Let's do 3 instead of 6 for now. If I divide that into thirds, we have 1, 2, 1, 2, 1, 2. And so how many 2/3 are in 3? Well, we have 2/3 there. We have 2 blocks there. We have 2 blocks there. And we have 2 blocks there. So I have 1, 2, 3, 4 and a half. Right? So this is 1, 2, 3, 4 and a half. And if I want to do 6 instead of that, I double it. So 4 and a half. So 4 and a half times 2 is going to be 9. So we'd say it's equal to 9. All right. So then we can do 9 times 2/3 equals 6. And finally over here we have 2 broken into 1, 2, 3, 4, 5 groups of 2/5. So we're taking the 2 and we're dividing it by 2/5 to come up with 5 groups. Or we can do 5 groups times 2/5 each for a total of 2. Alright, and number 6. At a farmer's market, 2 vendors sell fresh milk. One sells 2 liters for $3.80, another $1.5 for $2.70. What's the better deal? Okay, so we're talking about liters, and we're talking about the price per liters for one. And over here we're doing liters, and we're doing the price for the other. So one is 2 liters for $3.80. One is 1.5 liters for 2.70 cents. Okay, a couple ways of doing this here. So you can certainly go ahead and figure out how much 1 liter is going to cost. Right? We would divide. This would be divided by 2, divide by 2, and you can figure that out. This is divided by 1.5, right? Divide by 1.5. This is divide by 2. Just real quick, what I did, the different way of solving it here, is I recognize that with 1.5, if I multiply it by 2, I'm at 3. If I multiply by 4 times 4, then I'm at 6. If I multiply 2 times 3, then I'm at 6. And now those are in common and I can compare. So I did 380 times 3 for 1140, and I did 270 times 4 for 1080. Okay, does that work? Sure, I can say that this one here is the better deal, which is the 1.5 for there. If you did the unit price, how much for 1 liter, you would show that this one is actually going to be $1.90, and this one here would be $1.80. So they both work. This one just involved, the way I did it, use multiplication, because I like multiplication better than division most of the time, right? So I like that better. This one uses division. It doesn't matter which one you choose, they both work. Okay, the recipe uses 4 or 5 cups of flour for every 2 cups of sugar. So we have flour, and we have sugar, and we have our table, and we know we have 5 to 2 for that. How much sugar is used for 1 cup of flour? So if that became 1, how do we get to 1? This is going to be divided by 5, so this becomes 2/5. How about 1 cup of sugar? So if 2 goes into 1, that's divided by 2, so 5 divided by 2 is 5/2. Okay? And then for this one here, how much flour is used with 7 cups? Well, now we can do 7 cups of sugar. So if this becomes, my sugar is 7, this is times 7. So this becomes times 7. So 7 times 5 is 35 over 2. So we'd say 35 over 2, which is the same as 17 and a half. And then over here, if I'm going to do 6 cups of flour, that's 1 to 6. So I multiply 2/5 times 6. 6 times 2 is 12. And over 5, so that's 12/5, which becomes 2 and 2/5 as my answer. Okay, so that's what I have for number 7, and that's it for today in this lesson. Have a great day, and we'll see you next time.